It's hard to imagine that only a few thousand years ago, this area of Canada's Atlantic coast was covered by massive ice sheets. The ice would have been thousands of meters high, and the coast of the Atlantic Ocean 200 kilometers in that direction. Well, what happened? How could an area go from total ice cover to no ice at all? Why is it that the sea is continuing to rise, covering more and more of this coastline? Scientists know that these two phenomena are linked, and they continue to uncover new facts about the Northern Hemisphere's recurring ice ages. The glaciers continue to melt, and even though they're out of sight for most of us, the fact is that the last ice age continues to exert a profound effect over us, over our landscape, our way of life, even our livelihood. Eastern Canada looked like this 20,000 years ago, covered by extensive ice sheets which never stand still. They're like a treadmill, constantly eroding and picking up soil and rocks as they move, transporting the material hundreds of kilometers from one location to another. The shaping of valleys and the deposition of different types of material when the ice melts back has affected much of what we take for granted. The best agricultural land didn't just happen. Ice sheets played a key role in helping to create good soil in certain areas. Other material suited only for forest growth also was left by the retreat of the ice. Sand and gravel deposited by the ice sheets contains the groundwater used by many communities, and in other places is mined for use in the construction industry. The erosion and deposition caused by this ice controls in large part where we build our roads, where harbors and fishing communities have grown up, and even where our major cities are located. When you lie on the beach, did you ever imagine that the beach is there because of an ice age, and that effects of that ice age are still being felt? There have been many ice ages throughout the Earth's history. The most recent series of ice ages in the Northern Hemisphere began about 2.5 million years ago. Since then, ice has covered large areas of North America, Europe, and the Soviet Union several times. The last ice age reached its maximum extent 20,000 years ago. All of Atlantic Canada was covered by millions of tons of ice. Gradually, over thousands of years, the ice melted, clearing from the region about 10,000 years ago. When glaciers covered what is now downtown Halifax, the ice would have towered more than a kilometer over me. After 10,000 years of melting, those ice fields lie far to the north of here, but they still provide a visual reminder of what Eastern Canada looked like during the recent ice age. It's a major journey from Montreal north to the remaining ice fields. Even in the summer, much of this land is covered by snow and ice. The location is the northeast coast of Baffin Island, where small ice sheets still exist on high ground, providing a natural laboratory for observing glacial processes. Our destination is Pond Inlet, a small Inuit community of 1,000 people, one of the last northern stops by commercial aircraft in the eastern Arctic. Scientists like Jim Savitsky and Jay Stravers from the Atlantic Geoscience Center in Dartmouth, Nova Scotia, know this area well. Their geological investigations near ice sheets are adding to our understanding of how the process of glaciation works and how it has affected us. Pond Inlet, over 600 kilometers above the Arctic Circle. In July, the average daytime temperature is about 8 degrees Celsius. People here still carry on traditional hunting and fishing as a main source of their livelihood. Pond Inlet is located in the ancestral homeland of the North Baffin Inuit. When the Earth's climate was much warmer, the area was a temperate land of lush grasses and huge trees. But the ice ages of the last 2.5 million years have dramatically changed the face of the Arctic. As you fly over Baffin Island, you get a sense of how these ice sheets formed. The ice originated simply as snowfall. As the snow accumulated, it was gradually buried and compressed under its own weight, forming denser glacial ice. The ice sheets are squeezed outward under their own weight, so over hundreds of years, the ice gradually flows toward the edges where it eventually melts. The ice front moves outwards when more ice reaches the edge than is melted. The ice front retreats when melting is more rapid. During the Ice Age, the ice sheets extended all the way from Nova Scotia to Baffin Island, and in many places reached the sea as high cliffs of ice. But as the ice retreated, the ice edge moved back onto land, where the ice split into narrower tongues that flowed down valleys as glaciers. The freezing and thawing action that occurs at the base of a glacier causes erosion of these deep, steep-walled valleys. Sometimes the sea floods the valley and forms what we call a fjord. The ice melts at the edge of the ice sheet, and material carried by the glacier is deposited directly from the ice or carried a little further by powerful meltwater streams. The meltwater dumps the sediment it carries further down the valley, building out a delta into the fjord. For scientists like Savitsky and Stravers, these sand deposits can be used to unravel the sequence of events during an ice age. The animals that occupied these shells have been dead for thousands of years, but the shells are radiocarbon dated to give the exact age of the surrounding sand. Using small pieces of information like this, geologists gradually piece together the history of an entire ice age. The processes we see on Baffin Island today were probably happening in eastern Canada 20,000 years ago as the ice retreated. We can still see plenty of evidence for the ice sheets in our landscape, such as this glacial valley in Gros Morne National Park in Newfoundland. Low ridges like this one that snake across Nova Scotia don't seem related to an old ice sheet, but they are. These raised ridges are a signal that the ice was here and created a unique shape to the landscape. Ice sheets are very complex structures. On the surface, they look huge and docile, but there's a lot of activity inside them, at their edges, and at the bottom. The inside of an ice sheet is often full of water, formed by melting at the surface and at the base. The water flows through tunnels in the ice, carrying sand and gravel. This material is deposited at the bottom of the tunnel, and as the ice melts, it dumps the sand and gravel in long, linear mounds. Geologists call these features eskers. Many eskers in the Maritimes are important because the sand and gravel found in them is of high quality and used in highway and building construction. Another feature formed when ice sheets melt back is called a moraine. In this case, material collected inside and on top of ice sheets or glaciers is dumped at the front of the melting as a hummocky mound. This valley glacier on Baffin Island shows the rough topography characteristic of moraines. In areas like the Atlantic provinces, moraines have been revegetated in the thousands of years since they were deposited, but you can still see the bouldery surface showing through the vegetation, as on this low ridge near Yarmouth, Nova Scotia. Large volumes of water leave the glaciers as they melt, often forming deltas when they reach the sea. The town of Parsborough, Nova Scotia, is built on an old delta that formed when ice covered the low hills behind the town about 13,000 years ago. The sands that were deposited in this delta also act as an aquifer for the town's wells, as they do for many communities throughout the region. Other landforms characteristic of glaciated areas are common along Nova Scotia's eastern and south shores. They're streamlined, teardrop-shaped hills, usually marked by hardwood stands. The town of Lunenburg, Nova Scotia, was built on one of these landforms, left behind by ice sheets. Round-topped hills like this one are called drumlins by geologists. They were deposited by advancing glaciers, but since then, they've been eroded by the sea. That erosion has opened the drumlins up, allowing scientists to study them and to understand the history of the glacial events that created them. How have geologists pieced together the history of glaciation in Atlantic Canada? One way is to look at bare outcrops over which the ice has flowed. Near St. John's, Newfoundland, Bob Rogerson of Memorial University is tracing large grooves on the rock surface. They're caused by rocks at the base of the ice sheet being dragged over the bare rock by the ice. Smaller scratches have a similar origin. They run in more than one direction, revealing differences in ice flow at different times. Using this evidence, geologists have identified many advances during the last ice age. More information about the ice comes from the deposits of glaciation. Material forming these drumlin hills is called till. In this drumlin near Lawrencetown, Nova Scotia, there are two types of till, gray beneath and red above. Geologists like Ralph Stay of the Nova Scotia Department of Mines and Energy have confirmed that the gray till comes from the local area. The red till above it was eroded from rocks at least 100 kilometers away and transported here by the ice. Again, evidence for multiple movements of the ice sheets. Even the direction of the St. John River in New Brunswick was altered by glaciers. This is today's river. But before glaciers, the river emptied into the ocean at Sheldon Point, 5 kilometers from its present course. This old river course was dammed by the glacial deposits, forcing the river to find a new outlet. Research by geologists like Al Seaman of the New Brunswick Department of Natural Resources and radiocarbon dating of shells found in the uplifted material by geologist Linda Nix has given an age for the shells of about 13,000 years, confirming the time ice retreated from the St. John, New Brunswick area. So, if the Atlantic provinces were once covered by ice sheets, what's happened in the 10,000 years since? Clearly, one of the major changes has been the revegetation of the region. Evidence for the post-glacial history of tree growth can be found in sediments lying at the bottom of lakes. Scientists like Joyce McPherson and her colleagues at Memorial University in St. John's, Newfoundland, have cored deeply into ponds, looking for clues in the mud of the Ice Age timetable.
Yeah, here we are. It's rather pale.
They're looking for pollen grains from vegetation that developed after the ice left the area. Lab analysis and carbon dating have shown that sediments began to accumulate in the lake about 9,000 years ago. After a phase of tundra vegetation, spruce and fir trees began growing about 8,500 years ago, confirming the retreat of the ice and the gradual warming of the climate. Why does the Earth go through these vast fluctuations from the Ice Age to the more comfortable conditions of today? Scientists have discovered that these changes have occurred numerous times in the last 2.5 million years. In fact, there has been an almost regular oscillation of climate and glaciations. One concept is that the ice ages are related to small but regular changes that occur in the Earth's orbit and rotation. These fluctuations have been calculated to have frequencies similar to those observed in the advance and retreat of ice sheets. Although it seems like the events of 20,000 years ago no longer directly affect us, in fact, there is one important effect that's still going on today. The ice sheets represent a tremendous volume of frozen water, water that originally came mainly from the oceans. So, as the ice sheets built up on land, the volume of water in the oceans decreased and sea level dropped. The weight of all that ice on the continents acted to depress the Earth's crust under the ice sheet. The Earth acts something like a rubber ball, so that when the ice melts back, the Earth's surface springs back. However, this happens very slowly, and in some parts of the world, the rebound is still occurring. Near Cape Chignecto in the Bay of Fundy, this raised beach at the top of a cliff shows the extent of the rebound. Now 30 meters above water, this sandy top was actually once at sea level. It was first depressed by the weight of glaciers and has since bounced back as the ice retreated. A similar glacial event at an earlier ice age also stranded this beach near Antigonish, Nova Scotia. The beach is 4 meters above today's high tide level, confirming that at some time in the past, sea level was much higher. As the sea level rose again, trees were drowned. Evidence of these drowned forests is seen on Cape Sable Island and at other locations along the Atlantic coastline. The weight of the glaciers and the following uplift of land, coupled with the low sea level, made the topography of the Atlantic coast far different from what it is today. Large land areas, like today's East Coast fishing banks, were once above sea level during glacial times. When the ice retreated, the sea gradually drowned these banks, which are now important fishing grounds for East Coast fishermen. Sea level continues to rise in many parts of Atlantic Canada, and many communities along the coast appear to move closer and closer to the ocean every year. Records of tides have been kept at Halifax, Charlottetown, and St. John for many decades. They show that sea level is gradually rising. In the Halifax Harbor, where records go back to 1850, the Atlantic Ocean is rising at about 3 millimeters per year. Since the founding of Halifax, sea level has risen by almost a meter, and it's still climbing. Halifax Harbor has been altered and shaped by the recent ice age. It didn't always have a wide entrance. 10,000 years ago, Halifax Harbor looked like this, with a freshwater lake to the north and a narrow river outlet to the sea. As sea level rose, however, the mouth of the harbor was opened. Eventually, the northern lake was flooded by the Atlantic Ocean as the harbor widened. Halifax Harbor today, with sea level still rising. The Bedford Basin on the right was once the lake, which flowed out and down to the harbor. Core samples taken by scientists from the bottom of Bedford Basin include the remains of organisms which lived only in fresh water.
We carbon-14 dated the layer between the two sequences, and the date we got was 6,000 years before present. That means that the Atlantic Ocean flooded over the sill about 6,000 years ago, drowning the lake and turning it into the inlet it is today.
One important consequence of our rising sea level is that much of the coastline of the Atlantic provinces is suffering from erosion by the ocean. Scientists have monitored this beach near Chesuncook for 5 years and have shown that the beach is constantly being pushed back by erosion as sea level rises.
Roger, sand and pebbles.
The beach is now just a narrow ridge of gravel surrounded by the Atlantic Ocean. It remains precariously connected to the mainland and may disappear altogether within the next decades.
This depression in the beach crest, where the sea is washed through, is here because the sediment supply from the headland source has been insufficient to maintain the link as the rest of the beach has moved back. It wasn't here at all in '85 when we first started monitoring the beach, and we predicted then that it might occur, and lo and behold, within a few months it started to develop.
Local people remember when this drumlin was a complete structure. Today, it's almost half eroded. But the rocks and sand from the drumlin have so far supplied the sand and gravel for the beach. Trees and debris from the drumlin now litter the beach. The erosion is relentless. The rising sea level exerts more and more pressure on the unstable hill until one day it too will almost be completely gone. As the ice sheets continue to melt, they return more and more water to the oceans. The resulting sea level rise affects our landscape, our way of life, even the livelihood of many communities. Just a few years ago, here on the Nova Scotia coast, there was a thriving farm community. The house and barns were over there by those rocks, and the fields extended hectares seaward.
I can remember when the farm, a house and barn and fields and gardens was all along there.
This is the view of where the farm existed just a few years ago. Today, it's completely eroded, leaving only rocks and seawater. A similar view is shown in this black and white photo taken in 1927 from the seaward side of the farm. It shows the extent of the land that was eroded. The farm existed for almost 3 generations, but eventually it was simply overwhelmed by the sea. Harris Meisner farmed the land which was taken by the sea. He had to move inland and start again.
Well, it's all washed away now. But there's where I was born. That's where I was born is out in the ocean now. You take that picture there, you know. I can show you where grandfather's well was. That's out in the ocean now. Lots of water in that well now. Yeah. Go on.
The ice age of 20,000 years ago once covered much of eastern Canada with glaciers. The advance and the continuing retreat of the ice has greatly affected our environment. The types of soil and the types of agriculture carried out differ from area to area as a direct result of the deposits left behind by melting ice sheets. It's no coincidence that some areas have soils better suitable for agriculture and other soil only suitable for forestry. Our landscapes and harbors were also shaped by ice sheets, determining in large part where we build our communities. And the sand and gravel deposits left by the active glaciers have been of economic importance to all of us as a source of sand and gravel and for our water supply. Material left by the ice sheets has been eroded by the rising sea to form our beaches. Sea level will continue to rise in many places, and our coastline will continue to retreat. What can scientists tell us about the future? Most agree that we're in what's called an interglacial period, sometime between the last ice age and the next one. And if nothing else happens to affect the Earth's climate, you could expect that maybe by 23,000 years from now, eastern Canada would be covered by glaciers again. But nobody knows what the man-made impact of the greenhouse effect will be on that ice age timetable. One thing's for sure, though, the last ice age will still continue to affect our lives and our communities for years to come.